All right, we're back, and just want to remind everybody that we cannot control other people, and sometimes we can't even control ourselves necessarily. But we have the most control that we're going to have over anybody, over ourselves. So just try to remember that is really one thing that you possibly can control in this world is possibly you. So think about that. Power example number one, we're going to have two power equations. Number one, how much power, please be writing this down, how much power is used if 35.7 joules of work are used in 7.5 seconds. This could be like a blender. This could be a toaster. This could be some sort of appliance that is using energy over a certain amount of time, applying some sort of work in a certain amount of time. Always, always, always WTFF, write the formula first. In this case, your formula is P equals W divided by T. And this W is not watts. This W is work. Work per time. Work over time. Work divided by time. Power is work divided by time. You should be familiar with this theme now. You're going to plug in the variables. And if you're confused, which is the work, which is the time? Well, the time is 7.5 seconds, so the work has to be the other one. So in these simple examples, you can usually figure out what goes where. And for those of you who have done the calculator math, you should end up with something like that, 4.76 watts. However, look carefully, there are only two sig figs right here. And so your answer can only have two sig figs. That's your least precise measurement. 4.8 watts of power are used if 35.7 joules of work are used in 7.5 seconds. 4.8 watts. If you need to pause the video to write that all down, that is totally fine. If not, I'm going to move forward. Number two, this is the second power equation, the second version. It's all power, it's all work, but there are kind of two different ways you can be asked this, because remember, work itself is force times distance. So if you're not given the work, you will be given the force, you will be given the distance, and you have to know that these equations are equivalent. How much power is used if a force of 35 newtons is used to push a box 10 meters in 5.5 seconds? Make sure that you are writing that down. How much power is used if a force of 35 newtons is used to push a box in 10 meters in 5.5 seconds? So you got a box, it has a certain weight. We could measure that weight in pounds, but instead we're going to measure it in newtons. You're pushing that box 10 meter sticks along the floor, 10 meter sticks along the floor in 5.5 seconds. How much power did it take to do that? Well, remember, power is work divided by time, but work itself right here is force times distance. So always, always, always write the formula first. You could start off with P equals W over T, but remember that W is F times D. P is equal to F times D over T. So there's another version for power. Power is force times distance over time. How will you know which one to use? Well, if it asks you for power, you're going to know that there are two formulas for power. But if you forget and you're like, wait, power is force times distance. Power is work divided by time. I don't see any work in here. I see three things that should clue you in. You have a distance, you have a time, you have a force. So we're kind of using the variables to reason through the thinking on what these things mean. Power is force times distance divided by time. That should be 35 newtons. That's your force. Your distance you should recognize because that is in meters. Your time you should recognize because that is in seconds. Power is force times distance divided by time. So you wrote the formula first. You plugged in the variables. You could break it down a little bit more if you wanted to. 35 times 10 is 350. But most of you will end up with something like this on your calculator. 63.63, blah, 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 blah. Lies from your calculator. How many sig figs are you allowed? You have two here. You have three here because those trailing zeros count because that's a decimal. And you have two here because they're non-zero. You should end up with 64 watts of power. All right. You've had power force times distance divided by time. You've had power equals work divided by time. You've had work is equal to, where'd that go? Wow, this is crazy. Work is equal to force times distance. So we've got the two power equations. We have a force equation. You have a gravitational potential energy equation. GPE is equal to mgh. You have a kinetic energy equation. Ke equals 1/2 mv squared. Don't forget to bring along the exponent. Don't forget to divide by 2 once you get to the end. We have now energy, work, and power formulas. So your task, your mission is this. You need to get the yellow assignment. So you might need to pause the video right here and get the yellow assignment. And then once you have the yellow assignment, it is divided into 2 sections. There are level 1 problems on the first and second page. There are level 2 problems on the third and fourth page. Your mission for the rest of class is to get done with the level 1 problems. And then level 2 problems are not due right now. Whatever you don't get done in class is homework. I will collect these practice problems at the beginning of next class. I expect you to be working on these till the end of class so that you can ask people in class what is up. Here is what I'm expecting. Here's an example, and it's fine if at the end you want to just pause this and show this. So here is your assignment. Here is an example number 1. It's asking for kinetic energy. Always, always, always WTFF, write the formula first. For some of you, it might be very helpful to put a circle around each variable in the equation or highlighter it if you want. That's totally fine. Make a little note to yourself. kg, that means kilogram. That's 1,000 grams. That means mass. Okay, we got the mass. Traveling at 28 meters per second. That's a speed. That's a velocity. Circle that. That's going to be your V. You don't have to always write down how many sig figs are in everything, but if you're still struggling with sig figs, it is a good idea to do that. Write down the formula first, and then plug in your variables. Plug in your variables, taking note of your sig figs. Don't forget to square it if you're doing the kinetic energy. Then you get a calculator answer. Write that calculator answer down. That's great. Put that down on paper so you're not looking back and forth and making mistakes. Write it down. It takes like a second to write 6 numbers down. And then here's why we did scientific notation. Some of these answers, to write the right number of sig figs, you got to do scientific notation. You could also write this as 872,000. Not 872, but 872,000. You can't have that sig fig right there. You got to only have 3 sig figs at the end. So don't forget, write the formula first, plug in your variables, chug through the math, sig fig it, put the right units on at the end, put a square around your answer so I can see what I need to grade, and get all the level 1 problems done. Namaste. The light in me sees the light in you. Good luck. I will see you on Wednesday. Peace.